I want to take just a few minutes and talk about what can happen when you are trying to solve a linear equation. So I've titled this Types of Solutions for Linear Equations. And actually, there are three possible types of solutions to a linear equation. The first, and maybe what I would consider the most common type of solution, is you just get a number. You're given an equation, you're asked to solve it, and you end up with x equals 4, or x equals minus 1/2. Okay, that's sort of what we sort of kind of expect when we're solving a linear equation. But actually, there are two other possibilities. Sometimes you're given an equation and there's actually no solution. Sometimes in the world of math, you may see a symbol like sort of a 0 with a slash through it. No solution means there are no numbers that work for that equation that cause the equation to be true. In a minute, I'll do an example, and if this doesn't quite make sense to you, then you'll see an example in a minute. But then there's actually one more possibility. Sometimes you end up trying to solve a linear equation, and as you're working it out, you end up with a solution of all real numbers, which means every number is a solution. You're given an equation, you're asked to solve it, and as it turns out, 4 is a solution, 5 is a solution, minus 17 is a solution, 2/3 a solution. Any number you want is a solution. In this case, we say the solution is all real numbers. And all real numbers in the world of math, sometimes they like to write this R with the double lines here. So I think the easiest thing to do is just to do some examples of the three of these, so that when you come across them as you're solving these linear equations, you'll know what's going on. So we'll start here. I won't necessarily tell you what the solution is going to be, although it's probably going to be pretty evident after just a minute. So once again, when you're trying to solve an equation, I'm trying to find a value or a number for x that when I plug that in here makes this equation true. As a matter of fact, a lot of times after you solve an equation, you're asked to check your solution. And of course, that means you take your solution and you plug it back into the original equation and make sure it works. Especially on an exam, if you have time, when you're all finished with the problems, you should go back and always check your solutions. So if I want to solve this, pretty straightforward. I'm going to use addition and subtraction to get all the terms with an x on one side and all the terms without an x on the other side. So in this case, hopefully it's pretty routine that I'm going to subtract x from both sides. So I end up with 2x over here. And then let's move this -2 by adding 2 to both sides. And I end up with 2x equals 8. And if I want to solve for x, that means basically get x by itself. Well, right now, I've got x multiplied by 2. But if I divide both sides by 2, And then I end up with x equals 4, and this becomes my solution. If I want to check it, if I plug 4 back in here, this would be 12 minus 2 equals 6 plus 4. 12 minus 2, 10 over here, 10 over here. That confirms that this is in fact the solution. And this is what we sort of kind of think of as being normal. You're given a linear equation and you have one solution. You can see that's my first type of solution. Let's look at a different equation. How about nine x minus 6 equals 2 times 9 plus 2x plus 5x. So once again, I'm going to try and solve this equation for x. In this case, first thing I'm going to do is multiply out these parentheses, and then I'll combine like terms and move things from side to side, and I think you pretty much know how to solve this equation. So let's see what happens. So 9x minus 6, if I multiply out the parentheses, you get 18 plus 4x plus 5x. I need to go and combine like terms. So you have 18 plus 9x. Let's go ahead and get my x's on the left-hand side. So if I subtract 9x from both sides, let me just go ahead and show you this so you see what happens. So it's very obvious. So over here, 9x minus 9x, I'm left with negative 6. Then over here, 9x minus 9x, I'm left with 18. Okay, so here's what's happening. You're given this equation. Your ultimate goal is to solve for x, which means to get x by itself. Normally you have x equals a number like we had up here. So as you're following the steps to try and solve for x, all of a sudden, I like to say maybe it disappeared on his 1s. Anyways, the variable disappeared. So I'm trying to solve for x, and I follow the rules that I'm supposed to in math and algebra, and I don't have any variables. So sometimes this happens. Now, if this does happen, then you have to ask a question, and the answer to this question will determine then what your solution is. And here's the question. So you're working along, next thing you know, your variable's gone, and you're just left with two numbers on either side of the equal sign. The question you have to ask is, your variables disappear, and now you're left with two numbers. Are the numbers equal? Now, if the answer is yes, then that means the solution is, that symbol stands for all real numbers, which means every number is a solution. In a minute, we'll do an example about this and we'll look at that. However, in our case, when I ask the question, are the numbers equal? Turns out they are not. So when that happens, Turns out there's actually no solution. And oftentimes in math, you might see this symbol. No solution means if I go back to my original equation and I decided just to take the time and try and figure out a solution, and I would just start plugging in numbers. So if I plugged in 1 for x, would this be true? No. If I tried, well, how about 2? No. How about 0 for x? No. How about -5 for x? No. I mean, you can keep trying to plug in numbers for x for the rest of the day. Nothing is going to work. It turns out there is no solution for this equation. There's no number that I can plug in for x that's going to make this equation true. All right, so far I said there are 3 possible types of solutions when you're solving a linear equation. You can just have the solution be a number, which is what we sort of normally expect. But in this case, when the variables disappeared and the 2 numbers we left with were not the same, when that happens, it's actually no solution, which up here was listed as my second possibility. Now let's do one more, and obviously this is going to be an example where the solution is all real numbers. So let's look at this equation. Seven x plus 2 minus 2 times x minus 4 equals 5 times x plus 2. So once again, our goal is to solve for x. This case, I actually have 2 parentheses. So first thing I'm going to do is multiply out the parentheses and then try and go through our normal steps to solve this equation. So 7x plus 2. Be careful now because I'm subtracting. So when I multiply 2 times x, it's negative 2x. But when I multiply 2 times negative 4, it's really, you could think of negative 2 times negative 4. This negative applies also. So it's actually 8. Then over here, I have 5x plus 10. Now on the left-hand side, I need to combine some like terms. 7x minus 2x is 5x. 2 plus 8 is 10. Then over here, there's nothing to do. So now I would do what I usually do. I'll just try and put the x's on the left-hand side of my equation. So I'll subtract 5x from both sides. So 5x minus 5x is just 0. So on the left-hand side, I have 10. And then the right-hand side, 5x minus 5x is also 0. And I'm left with 10. So here's another example. I'm really trying to solve for x. I'm trying to get x by itself. And in the midst of going through my normal steps to solve this equation, the variables disappeared. And now I'm left with 2 numbers. Now, so like I said a minute ago, when this happens, you have to ask yourself the question, are the numbers equal? Now, in this case, the 2 numbers are equal. When that happens, that means the solution is all real numbers. That means every number is a solution. So I could write here x equals all real numbers. And just as an example, that means anything I plug in for x is going to make this equation true. For instance, let's do something simple. How about I plug in 0? So if I plug in 0 for x, this is going to be 0 plus 2. Now 0 for x in here leaves us minus 4. So minus 2 times minus 4 is plus 8. Then over here, if I plug in a 0, it's 5 times 2, which is 10. So 2 plus 8 equals 10. 0 is a solution. And I could keep going on. I could plug in 1 for x, and I'd see the same thing. I could plug in negative 25 for x, and I would see the same thing. In other words, every number is a solution. So that's what can happen when you're solving a linear equation. Turns out you can end up with 3 types of solution. Sometimes you get a number, which is sort of what we normally kind of expect, but you will also have cases where these 2 situations occur. Now let me do one more example, and this can be a little confusing. Now you've already learned how to solve equations that start out with rational expressions, right? Rational expressions is like another word for fractions. So let me just show you something interesting that happens here that a lot of times can be a little tricky and can be a little confusing for students. So here's this equation. I got a couple rational expressions. Of course, I still want to solve it. Now, if you recall, there's some steps you go through to solve this kind of equation that's more involved than the kinds of equations we've solved so far. Matter of fact, I'll just go ahead and do it. First thing I'm going to do is I need to go factor anything possible. 3x plus 6 can be factored into x plus 2. Over here, 15x plus 30 can be factored into 15 times x plus 2. Now, when we went over how to solve this before, we decided the easiest way was to clear the fractions by multiplying by the LCD. However, let me say this before we do that, and even sometimes I forget. A lot of times when you get to this point, when you have a problem, there's a rational expression, and you actually have your variable in the denominator. Before you even try and solve this, it's a good idea just to make a note that no matter what happens when you try and solve this problem, we know that -2 cannot be a solution to this equation. Sometimes in the world of math, you can do all the math correctly, and something sort of goofy happens where when you do the math will sometimes tell you that x equals -2 is a solution. However, the final check is always your initial equation here. Even if I do all the math perfectly and somehow the math tries to tell me that -2 is a solution, I know it cannot be the solution. This ultimately wins out. So a lot of times we write it here so that after we do all the math, the last thing we do is check and we make sure that our solutions are acceptable. Now, to solve this equation, we like to clear the fractions, which means I'm going to multiply both sides by the LCD. Now, the LCD, if I look at these 2 denominators, the parenthesis is the same, x plus 2. However, I get a 3 and a 15. So we've done this before where it looks like the LCD should be 15 times x plus 2. So what we do to clear fractions, we multiply both sides by the LCD. So now if we multiply 15 times x plus 2 times this first term, hopefully you notice that the x plus 2's cancel the parenthesis. And actually I'm left with 15 over 3 which is 5. So I'm left with 5 times 4. So that's this times this, minus now this times this. It looks like 15 times x plus 2 is actually my denominator. So this cancels out the whole denominator. And I'm left with this. And then on the right-hand side, it's just 0. So actually, what do I have? Now, if you think about it, first of all, my variables have disappeared. To make it very obvious, if I put these numbers on the opposite sides, then I really have 20 equals 20. So once again, that's the case where my variables disappeared. The two numbers I've left with are the same. So according to what we've talked about before, you would write down x equals all real numbers. In other words, when your variables disappear and the numbers you have left are the same. Up to now, we've sort of said the solution is all real numbers. However, this problem has a twist. And once again, anytime your initial starting equation has rational expressions, after you solve it, you still have to go back and check and make sure your solution is okay. Now, in this case, my solution is like all numbers. Like x can be anything. I can plug in anything for x and it will work. I can plug in 0 for x. So 3 times 2 and 15 times 2. And if I worked out all the algebra, do the calculation, I'm sure it would work. However, way back at the beginning, I said, no matter what the math shows me, when I get to the end, I know that -2 cannot be a solution. So what do I do here now? Because the math said, in a sense, every number is a solution. But up here at the start, I said, well, -2 can't be a solution. Remember what I said? This wins out. So actually what the answer should be, the solution should be all real numbers except x still cannot be -2. So in other words, for this equation, x could be 1, x could be 3, x could be 0, x could be 7, x could be 21, x could be -15. However, x cannot be -2. So this is sort of a interesting little twist on when you're solving an equation and your variables disappear and the numbers you have left are the same, and automatically you just think to yourself, oh, okay, this is the case where the solution is all real numbers. Well, yeah, it is, except you still have to take into account the initial rational expressions. So then this would actually be the solution. All right, so whenever you're solving linear equations, 3 possible types of solutions. So hopefully when you see those now, you will understand them and be able to determine the correct solution.